Good afternoon, everybody. So we're going to do an example where we're going to use the mean, the standard deviation, and z-scores to figure out what percent of students in some class have marks between these two values. Okay, so we're told that this class has a mean of 73 and then a standard deviation of 4.7, and we're asked to find what percent of students have a mark between two values, namely between 65 and 85, right? And so if you can imagine what this looks like on a normal distribution curve, we can draw our classic bell curve, something like this, right? We know we're going to have our mean down the middle. That's our 73. Okay. Now we get a standard deviation of 4.7, so we can add multiples of that standard deviation above and below, like we're used to doing. And so 4.7 above, I meant adding 4.7 above is going to bring us to 73 plus 4.7, i.e. 77.7, plus another 4.7, 78.4, and 82.4, and then plus 4.7, 83.1, 87.1, and then same thing on the other side, right? Minus 4.7 will take us to 68.3, minus 4.7 is 63.6, and 62.9, 58.9. Now, I only do this so that we can visualize at least an estimate of what your answer should look like, because we know that the rough averages of the amount of data points that fall within these multiples of standard deviations on a normal distribution are pretty consistent. And so these can give us a pretty good estimate of the answer that we are looking for. Okay. So those are our percentages. Now we want to know the percent of students that have a mark between 65 and 85. Now 85 is, you can estimate between the second and the third standard deviation, somewhere around here, 85. And then 65 would be somewhere around here, let's say, right? And now that gives you at least a ballpark to work with. So we know there's going to be 68%, an additional 13.5%, so that's 68 plus 13.5, that's 81.5%, plus a bit of this and a bit of that. So we're already looking at probably 85 to 90% of students, okay? And now we can use our z-scores to actually get a nice precise value. So let's start with 65. So I'll do the z-score for 65. I like using this kind of notation, the z-score with a subscript of 65, just for notating the z-score for the value of 65, right? Is found by 65 minus the mean. The mean is 73. So 65 minus 73 divided by our standard deviation. And that means negative 8 divided by 4.7, which is, I'll need a calculator, negative 8 divided by 4.7 negative 1.7, 1.70. So that's our first one. And then we'll also need the z-score for 85. So I'll do z sub 85. And we use that same z-score formula, right? Our data point minus the mean of 73 divided by our standard deviation. 85 minus 73 leaves us with 12 divided by 4.7. And that should be 2 point something. Let's compute that really quickly. 2.55 to 2 decimal places, because that's what our z-score table is accurate to. And so now we have our two z-scores, and so we can look for the percent of data sets that fall below these two z-scores on a z-score table, right? Again, the z-score table tells you the percent of data that falls below to the left of the data point that you use to find your z-score, okay? So we'll find a percentage of, let's say we find a percentage of 95 For this one, that means 95% of the data falls below. If we find something like 3% for this one, that means 3% of data falls below. We want to know the percentage that is between these two, right? We want to know kind of all of this region, right? So on your Z-score table, we know that we've defined the percent that lies to the left of 85. Then we're going to find the percent that falls to the left of 65, and we'll subtract this little region that we don't want from this entire region, leaving us with only our region of interest, the stuff in between, okay? So, if you have a Z-score table handy, you can find it online as well. The percent of data that falls to the left of negative 1.70 is 4.46%, and the percent of data that tends to fall to the left of a Z-score of 2.55 is 99.46, right? And again, if we're interested in the amount of data that lies in between these two Z-scores with these two data points, then we're going to do this percentage, right? This is the 99.46% that lies to the left of this Z-score, and we're going to subtract the 4.46% that lies outside of the in-between region, right? So, percent of students, I'll say in between 65 and 85 is 99.46% minus 4.46%. That's 0.46. That's awfully coincidental, but we'll go with it. Which is exactly 95%. That's a nice number. And there we go. So we would expect in an average classroom with this mean and standard deviation that roughly 95% of students would fall in between 65 and 85 for their final marks. And there we go. Hope that helps, and thanks for watching.